Okay, here we go. All right. So as you're writing this down, specific to this book, which 2.1 through 2.3. That's what you had your quiz on yesterday. That was coordinate trig primarily, right? And that is, when you have a coordinate plane, every angle measure starts off, based off of, in standard position, which means you start at the positive x-axis. And if you go this way, this is a negative angle measure. If you go this way, that's a positive. And then we did trig on, angles that land in any of the four quadrants, whether it be a negative or positive angle measure. And then you have, 30, 60, 90s are important, 45, 45, 90s, blah, 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 blah. Then, I did already do 2-4, and I told you 2-4 has nothing to do with that. And I don't know why. The book does weird things. Maybe, like I said, when I did 2-4 notes, this is like review. So let's cram these two separate concepts into one chapter, and then we have 5 sections worth of stuff. Okay, that's how you have to look at it. So basically, you have to have 2 files in your brain. You got to put this file and put that file away for a second. Put it in the filing cabinet, and it has nothing to do with what we're going to do today. Nothing at all. All right, and those that can't do that filing, you're going to have some troubles. Because now we're going to do 2.5, which if you've been in Math 3 Honors, you know what this is. And if not, this is probably brand new. I doubt I don't know where you'd see this in any other class. And I'm sure you've heard the word bearing. Bearing is the bearing of some plane, train, or automobile. How many people have seen that movie, by the way? There's a lot in first hour, planes, trains, and automobiles. Oh, you kids make me sick. Are you serious? It's a great, actually, one of the rare Thanksgiving movies, actually. Life and friendships. All right. Anyway, so we've heard the bearing of the plane is. All right. So here's what you're going to have to separate. Then I'm going to go back to the file thing that I had over here. One way is this way. I know you have 4 things here, but these are 4 different bearings of the first way of saying the bearing of a plane. First of all, it is an angle that is going to be between 0 and 360. No more, no less. No negative angle measures. Just the bearing is. And it could be anything from 0 degrees to 360 degrees. And then I don't know who did this. I'm just the informant. When they say a bearing between 0 and 360 with no other information, you are going off of the north axis. And you are going in a clockwise direction. So the bearing of a plane is 32 degrees, and that's all you hear. That means the plane is flying in that direction, that red line there. So make sure you understand that if you need to draw a plane, you go right ahead. Here's where the plane is. It's going in this direction. Look at my plane. 3 years of art. Actually, it just looks like a person if I put a head on it. I don't know. Okay, just pretend that's a plane. And that's where the plane's flying. Or the bearing of the plane is 164 degrees. So how are you supposed to... Okay, so off of the north axis, I shouldn't have put that red line. The plane is flying in... By the way, what direction would that be? How would you describe that with 2 things that you know about when you're talking about directions? South what? East, the southeasterly direction. So you get that. It's on a map or whatever, what have you. Okay, and you get it. The plane is flying in this direction, which is southwest. If it's on a bearing of 229, and then a bearing of 304, it's going northwest. That's the plane's actually flight pattern. Okay? All right, so that's the thing. That's why I started with this. When you get to 2.4.2.5, it has nothing to do with coordinate trig whatsoever. 2.4 was solving triangles with positive angle measures and positive side measures. All right, just to build up to 2.5, where you don't have a coordinate plane, you have what's called a compass. And everything is based off, is it east over here? And then west over here? It's not a coordinate plane. Nothing to do with it, although we're going to confuse you. Our first set of notes talks about a coordinate plane. all right? And it's not the same as what we did in 2-1 to 2-3. So not a coordinate plane. It's a compass. Okay? All right. Here's the second way. I like this way better. This one's a little bit more direct because this one you have to remember. All right, in coordinate trig, counterclockwise is a positive direction. In bearings of this method, clockwise is the direction that we have to go. Right? Right? Do you see that? Okay, so that's something you're gonna have to figure out. I don't know. You just wax on. A dog has 4 legs and what? Did I ever do the dog reference? No, it's like some people say, I don't get it. No, you just don't have it memorized. It's like a dog walks in a room, look, a cat. No, I'm sorry. That's a dog. Why? I don't get it. What do you mean you don't get it? It's a dog. How do I explain a dog? It has 4 legs unless it got majorly injured, and it barks. I don't get it. There's no I don't get it sometimes. You don't get, you're not allowed to say that. You got to memorize, all right? And that's sometimes what it is. And this is what you got to memorize, and memorize the difference between these sections when we take the Chapter 2 test. All right, here we go. Here's the second way. Right here. And I segmented the notes a little different way back in the day, so I have to kind of move around. The second method, if you want to write these down, this is specific, but the key is look at the difference. That's how they're going to express the bearing. A little more specific. And I should have this down here. This way, you will have an angle measure that is only between 0 and 90 degrees, not 360. And it's specifically off of either the north or the south axis. That's why. So this first bearing over here is north, 42 east. That means 42 degrees off of the north axis in an easterly direction. The plane is flying in this direction. So that's where the plane is going off to. Or, let's stick with the norths, north 52 degrees in a westerly direction. So it's more direct. All right, then the other two, south 31 east, the plane is going in this direction. And then south 40 degrees west, the plane flies off in that direction. So I gave you a minute to write these down. This is just a memorization factor. Now, okay, I guess as you're writing this down, something to keep in mind. We're going to have questions where you're going to have to solve, like how far did the plane fly? Or how far are these two planes apart? And you're going to have to make triangles out of this. In Chapter 2, we're only talking about right triangles. So accidentally, through our word problems, we will only get right triangles. When we go to Chapter 7, bearings are coming back because Chapter 7 is about non-right triangles. And you're really going to have to be good with bearings in Chapter 7 to get the right angle measures that don't end up being right triangles. All right, so again, hopefully you understand it. You can only do SOHCAHTOA. So, by the way, is what letters? Sine and what's O and what? How can you have a hypotenuse and not have a right triangle? You get what I'm saying? SOHCAHTOA is right triangle trig. There's a hypotenuse. All right? So, yeah, just to make sure you understand that. Okay. Now I said this has nothing to do with coordinate trig. But then they don't we put the world in a coordinate plane sometimes, right? Latitude and longitude is its own little special coordinate plane scenario. It says to give you more time to write that. You don't have to write every single one of those. Oh, here it is. Okay. Well, please read this question before you convolute this, what this means to the question. An observer for a radar station is located at the origin. Okay. For each of the points in 5 through 12, I picked 5 and 7 out. Find the bearing using both methods. That's really all you really have to say about that. Okay? All right. I will press pause. I promise I was in pause before. Okay, here we go. All right. So I just said it's not the same as coordinate trig, but then we had these questions. Okay. Whoa. Okay. I'm going to try to leave this right here. So remember what we said. All right. I'm going to leave the black there. Then I'll reveal what's behind it, which is the answer. But I'm going to write in yellow here. All right. So there's your coordinate plane. But let's not treat it as a coordinate. Let's do it, but then also treat it as a compass. And I'm gonna use the word compass a lot, so that you can get this question written in both ways, I guess is the best way to say it. So first of all, negative 4, 0. Here's they're at the origin. I'll pick purple for like these other things. So that didn't work. 1, 2. Okay. Purple right there is where the observer is. And the observer sees a plane. Did it say an airplane? Located at this position, which means this is the bearing. And the plane is like going in that direction. But at the time that it looks, it sees it's at negative 4, 0. So what's its bearing? Well, the first way, I'm just going to, just teach. I'm not going to ask you. Because if I'm going to pretend it's first hour, which they don't answer anything anyway. They just stare at me like I'm the devil. In a public school, how dare they? You got to go off of the north axis in a clockwise direction. What is the bearing then? Come on, what's that angle measure? You don't know that. We got some problems, man. That's 270 degrees, so the bearing is 270. Now, here's where it gets weird. Let's pick orange for the next one. I have two ways to do this because the other way, the angle measure has to be between what? 0 and what? 90. So I have two ways I could do this. I could say off of this axis, it's 90 degrees this way, or off of this axis, it's 90 degrees this way. This is one of the rare times you have two different ways you could do the other way, because the other way has to be between 0 and 90. So I have two ways. It's either north, then 90 degrees west, or south, 90 degrees west. And you just got to learn both ways. They're both different, and I don't know why they both exist. Who knows? Okay, I'm just the informant, like I say. All right, so here we go. Oh, we got to pause. We got to pause. Oh, hold on. You're freaking me out, man. I don't know which button to hit. All right, all right. And then you got to figure this one out. I mean, it ain't no thing. Chicken wings made out of bugs. We were talking about this. Do I still have it up? Let's see. I better be careful. Oh, no, you're on the internet. All right, sorry. You can sue me. Go ahead. Just go ahead. I think I've had enough anyway. And I'm getting ready to eat bugs. Look at this. Get ready to eat bugs if you want to live beyond 2050. Isn't that scary? But then, like I say, I think KFC's already done it. They made chicken out of bugs over here in the corner. So anyway, interesting story. Sorry. That's what you get in Samuels's class, that weirdo on the internet making comments might say something now. All right. Okay. So, negative 5, 5, right? 1, 2, 3, 4, 5. Hey, what kind of triangle is this? Purple. 3, 4, 5. Okay, what kind of what kind of triangle is this if the plane is like that and then I completed a triangle? What kind of triangle is that? Right triangle. I need more than that. Come on. What's the I know I shouldn't be saying reference angle. What's the reference angle? What's that angle touching the origin? 45. All right. So, the first way is off of the north axis. What is this angle measure? Okay, hold on. How far have I gone right now? This is not rocket science. Look up there. How far? 270. And then how far? If this is 5 and negative 5, that's positive 5. And this is negative 5. They said that was a 45-degree angle in there. And they're right, because it's isosceles and it's right. So it's got to be. So what does that end up being for that angle measure? 315. Now, I know this has nothing to do with coordinate trig. It's just angular movements. And then there's only one way you can name this one, because the angle must be between 0 and 90. So it's that way. That is north, off of the north axis, also 45 degrees in a, that's not a northwest, westerly direction. So these are the two ways that you can name that. All right, already taken too long on this. The next thing I'm going to warn you, not as colorful. I just wanted to, write it instead of just shove the answer in your face, because this is my old notes that are stuck here. I assigned an assignment that has all of the drawings for you in the next section. Now, let's look at this question, and then as you write it down, listen to good old ugly Mr. Samuelus. There is a word problem. And in tonight's assignment, I purposely picked out the ones that have the pictures with the word problem. I know what some of you bums do. When the picture is complete, do you even read the word problem? Yes or no? No, some of you don't. You look at the triangle, I don't have to read that, and then you solve for x. I'll show you how easy this drawing is. It's, and I'm going to flash it and then make it disappear. Boom. Do you see all the angle measures you need plus the missing b that you have to find? I guarantee the majority of you would not even read the question. And I'm going to tell you right now, you can lead a horse to water, but what can't you do? Can't make it drink. You should, first of all, thank Mr. Samuelis for assigning all the questions that have a picture. Second, cover the picture with maybe a sticky note if you use the old-fashioned book, or zoom in so you don't see the picture. Read the question, try to construct your own picture, then look at the picture provided in the question that I assigned and see, because that's what's going to be difficult. That's what you're going to have to accomplish on the test. Because if you don't get the picture, there's no way of getting the question right at all, and you will get no credit. All right? So tonight, let's say there's 4 questions. If you're able to get like one drawing correct, you're actually better off probably than most. I don't want to shortchange you, but you're probably in decent shape. And some of the other ones you're close, then you're probably in really good shape. And if you don't get any drawing right, we have a geometric problem. Or you can't memorize bearings. You just don't know like how to. I don't know what I can do other than explain it over and over again. Now here it is again. What should you not have touched yesterday on the quiz? The sine, cosine, and tangent button. You know how many people in this hour actually still use the sine button to answer a question? There's nothing I can do. So if you sit here and don't read any of the questions and you just solve by looking at the pictures given, you have done absolutely nothing. You're actually in math 2. You're a sophomore. You went back to your sophomore year and just reviewed and did nothing to get ready for your test Tuesday. What did he just say? All right, now this is 2020. I'll probably use this video the next 6 years as I if I make it, if I don't get fired by then. So if this is 2021, 22, 23, 24, 25, 36, the test may not be Tuesday. You get it? But in 2020, the test is Tuesday. Okay, so I'm just rambling on. Hey, why don't you try to make this drawing based off of what you know? And I swear, if you get this drawing right, holy crap, you're in great shape. That's like really good. Okay. I think I'm like in purple. First of all, is this A and B? Oh, it's frozen. Let it go. Not on the internet though, but in class. Is that where A and B are? I can't. Every person's drawing should be exactly the same. It always I get baffled on like how triangles can be all flip-flopped and things are all over the place. What is an east-west line gonna be? Left and right. Okay, I tried to hit that button. There we go. Oh no. No. Okay. Oh, whew. Okay. So I want to construct this. Now, I will tell you that there's nothing in there that says A is on the left and B is on the right. You shouldn't assume that. I could create a question where actually B is on the left and A is on the right. It all depends on the next thing that you read. So A and B are in an east-west line. I don't really know where A and B is yet. That's the real smart way to approach this. Oh, and they're 3.7 kilometers apart. First hour, I forgot to write that down. So of course we can write that. I just don't know if A is to the left or right. I already said that. Station A detects a plane at sea on a bearing of 61 degrees. First of all, where's the plane on the map? Above or below these points then? It's above. And now, you know why I know? I keep reading, and then the station B, and this is what you should do before you start a drawing. Before I put A and B down, you should kind of try to visualize the picture. Station B simultaneously detects the plane on a bearing of 331. I know now that A is over here and B is over here. How many other people knew that because of this? Because the next thing, this is what you do, and this is the trick on bearings. You actually put a compass on the given points of, on a bearing from. It's not a coordinate plane. This is a compass. North, south, east, west. We know what those are. I'm going to get in the way of the question if and actually all I need is north because if this is the bearing, this is the way of just saying one angle measure. And you said you knew C was above. It's because this approximately is 61 degrees. So C is somewhere along this line of sight. Don't put C down yet. It's somewhere along that line of sight from station A. That's why I know A is on the left. Well, also putting together with B what their information is. From B, that means we need a crosshair on B. No crosshair, you're doomed if you don't put these crosshairs. 331 is like this measure, 270 plus a few other degrees, which we'll mathematically find out. Oh, that's where C is, the crosshair between these two lines of sight. Now I can put what C is. And what do I have? I have a triangle. Now you're lucky. Since this is a direct, oh, and by the way, you should be doing this. You should be writing these angle measures because the next thing is it's all geometry. And those that are really poor in geometry, it's the only reason we're poor with these bearings. Or we just can't memorize. Those that can't memorize things, that there's nothing I can do for you, right? But here's the next thing. We have a triangle. Do we have any of the angles inside the triangle? Yes or no? No. Okay, but I can find that first one on the left. It's so simple. It's great that we have an east-west line. This has to be 29 degrees then because 61 and 29 add up to 90. It's the simplest geometry ever. The next question, not so much. And then the simplest geometry ever, 270 plus what is 331? Is it 61? That has to be 61 degrees. And what did I tell you? We have to end up with a what kind of triangle? So in these bearing questions in Chapter 2, we must get a right triangle because that's the only way we know how to solve triangles right now. Chapter 7 is non-right triangle trig. How many people have heard the law of sines and law of cosines? Raise your hand. Okay, that's what we're going to have in that chapter. All right, I'm going to get rid of the beautiful picture and put my original, what I had here. But then I'm going to show you my whole point that I made to begin with. You're a silly fool if you take this question and then, I have a drawing. I don't have to read the question. I'm just going to solve for B and not even know what B even means to the question. You are at a sophomore level of, and you are getting nowhere for yourself. I assigned the questions with the picture so that you could cover it, try to get it, then use it as a learning tool. Oh, I was close. All right? And then go from there. Because look at how ridiculously easy it is to solve for B, or in this case, I put X. If you use 61 degrees, X is opposite that, and 3.7 is the hypotenuse. Who's opposite over hypotenuse? Because I still have some people that are struggling on that. All right? Or if I use 29 degrees, what is that? Cosine. Either one will give me whatever the answer is. All right? So 39 or 29 degrees, 3.7, and x is the adjacent side, so it'd be cosine. Okay? All right. I'll stop just for a second to take a breath. All right. So I did tell my students you should read the question and then maybe read it again before you start. Try to picture the picture in your mind, then start putting stuff. Because your picture, it all has to look the same. Our pictures need to look the same. There is no two ways about it. I'm not going to get I went through this first hour. Protractor or compass? Which is the one that measures angles? Protractor. I got a way to remember that, by the way. Compass. You know how they have that little needle at the end? You could stick someone right, all right. So then I remember a compass is the thing that draws circles, and then the protractor. All right, I got it. Okay. I had to go through that first hour. I forget every time. You're a math teacher. How could you? All right. So where is C? Is C above or below A? Where is C? It is below. You're right. I'm sorry. You're correct. All right. And then where is C? Right or left of A? This is what I mean about where everyone's drawing should be the same. Right and below. Because C, do I have enough space? Okay, I'm going to have to put more black here. Yeah, because I want some space for this drawing, and I'm going to erase all this. Okay, so C is from a 2C. Oh, okay, actually, I'm in the wrong. I have the C left over here from first hour, and I'm trying to make it work. So bearing from 8 is South 50. I'm stumbling here. So A is like right here, and you put a crosshair on it. And then this is south 52 east. Yeah, that's about close to what I have as a drawing there. I tried to make this work. All right, and again, this is where I'm not going to get a protractor to measure that angle. And actually, I should just draw a line. That's the line of sight of it until I get another thing. So having C there is kind of screwing me up right there. But if I try to erase it, it'll erase all of this stuff and be a problem. You want to mark these things. This is 52 degrees. And I'm going to try to make this happen. Bearing from A to B is north 84 east. So where's B, above or below A? Barely, right? And then where's it, right or left? Above right. So now I can take and find B's position, and that's like 84 there. Now I'm going to see if I have something else there. It's a real small sliver. That's a line of sight there. Then this is where this gets tricky. Okay, fine. I think first hour I did write C's point down, and then it got me stuck where I could put B. Now look at this bearing from B to C. South 38 west. Okay, where is B? It's obviously above C, but is it right of C or left of C? So bearing from B to C is south 38 west. Where's B, right or left? Right. Okay, so B is somewhere around here. I'm going to try to make it happen to make that 38 degrees make sense. Now this is where this gets tricky. And I'm going to make this go way out here, this horizontal line, for the compass. It'll be real obnoxious. You, Mr. Samuelis? No way. South 38. I really don't like where I put that. Does that look like 38 degrees? Maybe. Do we care? Nah, not too much. I'm not going to get the protractor out and measure. But I do want to do this. This is 38 degrees in this little sliver. Then when you look at this, do I have any angles inside the triangle? Yes or no? Actually, no, you don't. But you can find them. You don't have any inside the triangle. Okay, oh, and I forgot to write this. This was 84. One of them is going to be easy. This one should be no problem geometrically. What's this angle measure from here to here, all of that? What would I have to do mathematically? 180, anyone? Minus 84 and minus 52. And I believe that's 44 degrees. Now remember, in Chapter 7, we're going to have to know how to find these angle measures. But I bet you could guess which one's the right angle. Which one looks like might be the right angle? Looks like angle C, but you can't guess that in Chapter 7, so we're going to have to do our due diligence here to find this angle measure. Now, is this one 90 minus 38? Yes or no? That's what a majority of the students are going to do, is it? No. 90 degrees is from here to here. You know, the west and the south axes. So we got this little sliver here. I'd like to know what that angle measure is. Guess what? It's equal to this angle measure. Why? These are alternate, anyone? Interior angles. So that's what I really had to. Now this is not part of the 44 is already done. All right, but what is that little sliver here based off of that 84 being up to that point? What is that? It's a measly 6 degrees in here. All right, that's this little sliver. So that's 6 degrees. So now how do I find that yellow angle measure? It's 90 minus 44. Oh, I like how he did that. I didn't quite do that in the other class. And that's where it's going to be a problem, knowing that that's alternate interior angles and then getting 46 here. So you have to understand all of this angle is 44, but I did need that little sliver of 6 degrees to figure out the angle across the way. All right? That's the big problem people do. They assume 90 degrees and do just 90 minus 38 for that other angle, and it's wrong. Okay, you have 90, so 90 is left over. Great, it was a right angle there, so I can do SOHCAHTOA to solve for this. All right, now is the time to erase all of the black and show the book. Look at all that stuff they give you in the book. Just imagine. You know, you're reading a word. Wait a minute, I got the drawing right there. Why would I even read it? Look, they even tell me I can find B. Sophomore, okay? And you're doing nothing for your CAT class. Right, and then there's my original drawing with the other class. And then There we go again. Once the drawing's over, it's infinitely easy. Opposite 46 degrees is what they asked. What's the distance from A to C? It's in the question. And they told you the distance from A to B was 600, so it's a sine. So, or you could choose cosine of 44 equals x over 600, and we get the same answer for what x is. So I cannot overemphasize. Getting the drawings is the challenge. After that, the trig is ridiculously easy. All right? All right. There's going to be one of these questions. I'll probably cover this tomorrow. I'll be honest, this question's extra credit on the chapter test, and some will maybe want to tackle that. So we're done. Hasta la vista.